tutorial on Ticket to Victory module chapter 1 and chapter 2. Let us discuss on question 1 structure. Okay, table 3 shows 5 substances and their respective chemical formula. Okay, let us classify their type of particles first. Here, iodine will be in the form of molecules. Okay, lithium is a metal, so it's in the form of atom. Okay, naphthalene, okay, it's a molecule combination of non-metal elements. Okay, non-metal elements, so it exists in the form of molecules. So magnesium oxide is a combination of metal and non-metal element, so it will be in the form of ions. It's an ionic compound, ions. Okay, same goes for copper oxide, combination of metal and non-metal. Here, so both exist in the form of ions. Okay, okay, let us look at the question. Okay, table 3 is actually combination of compound and elements as well. Okay, some exist in the form of element. Okay, so change the question a little bit. Okay, state one substance. Okay, cut the word compound, change it to substance. Okay, that will be more appropriate. Okay, state one substance from table 3 which exists as an atom. Okay, so we have already classified in advance just now. Okay, so the only substance that exists in the form of atom will be lithium. Here, when they say state, you can either answer by stating the name or writing the chemical formula. Okay, so that means if we write the name, lithium is accepted, or Li, both is accepted. Okay, okay, because they said state can be both. If they ask to name, then you have to follow instruction, then you just have to write the name. Okay, so that will be 1 mark. Okay, next question. Name the process of change in state of matter. Okay, name the process of change in state of matter when solid iodine is heated to form iodine gas. Okay, they are asking what is the name of the process that changes from solid to iodine gas. Solid to gas will be sublimation. Okay, next. Okay, diagram 6.1 shows the temperature against time when liquid naphthalene is cooled from 90 degrees to 30 degrees Celsius. Okay, so this will be the freezing point. Okay, when the temperature is constant, we refer it as the freezing point. Okay, here the temperature is constant. Temperature is constant. Okay, so state the type of particles. Okay, okay, when they ask type of particles, there's only 3 options. Either it is an atom, molecules, or ions. Okay, so we have already classified just now. Okay, naphthalene is a combination of non-metal elements only. Okay, that means we consider it as molecules. Okay, combination of non-metals only will be molecules. So this one, the type of particle will be molecules. Okay, then next question. Based on diagram 6.1, state the freezing point of naphthalene. Okay, so I must understand that freezing point actually refers to the temperature. Refers to the temperature where freezing occurs. When freezing occurs. Here, when freezing occurs, meaning go back to the graph. So The temperature is constant when it is freezing. So that means answer will be 83 degrees Celsius. Okay, yeah? So with unit, state the unit lah, 83 degrees Celsius. So with unit. Okay, and then explain why there is no change in temperature from T1 to T2. Okay, yeah? That is because heat energy released is balanced by the heat energy liberated to attract the particles to one another. Okay, next. If liquid naphthalene is cooled too quickly to solid without continuous stirring during the cooling process, sketch the expected curve in the space provided. Okay, yeah? So during the cooling process, we are supposed to stir the liquid of naphthalene continuously. If we fail to stir the naphthalene continuously, what happens is that supercooling occurs. Okay, yeah? Supercooling occurs. So supercooling graph will be slightly different. So the temperature drops and then goes back again, then drops again. Okay, yeah? So that means this is how the graph of the supercooling, when supercooling occurs lah. Okay, yeah? This is how the graph looks like when supercooling occurs. The freezing point is the same, which is 83 degrees Celsius, but only thing is that the temperature drops rapidly and then it goes back to 83, becomes constant, then it will reduce back again. Okay, we move on to the next part. Part B. Here, diagram 6.2 represents an atomic structure of the nucleon. Here, so they are asking us to label the symbols. Okay, so we call this as the subatomic particles lah. In an atom. Okay, atom. There are actually three types of subatomic particles. Okay, which is protons, neutron, and electron. Here, so the proton and the neutrons. Here, the protons and neutrons are found in the nucleus. Here, nucleus will be in the middle of the atom. So this will be in the middle of the atom. Here, so electron will be positioned in the shells. Here, shells will be occupied in the shells lah. Here, electrons will be found in the shells lah, around the nucleus. Here, okay, so that means this will be the electron. Here, so label here as electron. Here, so for a neutral atom, the number of electrons will be the same as the number of protons. That means the total number of electrons will be the same as the number of protons. Here, so meaning here we have 3 electrons. So in the nucleus, you have to find the same symbol of 3 protons. So that means you can see the yellow circle, actually there are 4 circles, and the dark circles, there are 3 dark circles, meaning the dark circles is referring to the protons, because the number of proton has to be same as the number of electron. because it's in atomic state. Here, so meaning it has 3 electrons, so it should have 3 protons. So the dark circle should be the protons and the yellow circle will be the neutrons. Okay. Okay, now we can calculate the nuclear number. Okay, the definition for nuclear number will be the sum of number of protons, and neutrons. Here, sum of number of protons and neutrons in the nucleus of an atom. In the nucleus of an atom. Here, this will be the definition. Here, normally we must memorize the definition. Important, has been tested quite a number of times in the exam. Here, so calculate the nuclear number. So in this case, go back to the diagram. You have 3 protons and 4 neutrons. Here, so 3 protons and 4 neutrons. So total will be 7. So the nuclear number should be 7. Just write that 7. Okay. Okay, that's it for question number 1.